Hi, I'm Dave Robinson, and welcome to another episode of my screencast where I use R and RStudio to analyze a dataset I've never seen before. So as usual, this dataset comes from the Tidy Tuesday project, which from the R for Data Science online learning community, which every week releases new datasets to have people work with them and learn about exploratory data analysis and visualization. So I'm really excited let's see what we have this week. It's another Seattle data set. It's Seattle bike traffic instead of Seattle pet names. I'm a pretty big fan of biking. I sometimes bike around New York, I guess because I have a death wish. And let's find out what kind of data we have. It's 12 bike counters. Okay, 12. So there's only 12 locations then? Huh. Yeah, looks like there's streets, direction, number of bikes passing each way, number of pedestrians passing each way. Okay, so let's load up the data. Let's see what we can find. As usual, I work within an R markdown. I'm going to save this one as bike traffic. Yeah, bike traffic. I usually start with library tidyverse. This is a big one maybe? Maybe we just have a slow internet. All right. Bike traffic. Oh, it's pretty big. 500,000 observations. So this looks like it's by hour. Oh, that's pretty cool. Okay, so we have we should see 12 crossings, I think. I see only 7. Okay, so it looks like maybe we don't have all the 12, and I saw 12 bike counters, 4 which also count pedestrians. Maybe there's their combination of crossing and direction that are 12. Well, now there's 13. I don't know what to make of that. Yeah, I don't think that was the It's a little odd to me. What it looks like I see here is we have each of them have north-south in each of these trails. We also have the greenway. We have just south trail. I've actually never been to Seattle, and we see the number of observations of each. Okay, so the data, it looks like they're always always identical between north and south. So that means it looks like our data is hourly stats. Let's find out what distribution of time we have. Date. Sometimes we just do a date histogram. And I'm also going to facet by crossing. X variable discrete. Oh, we need to parse the day. All right, so that actually we can do. What I'm going to do is save this as bike traffic raw, and have our since it's a large data set, and have the processing step happen afterwards. I'm going to say in date, even though it's really date time. I think the lubridate package has a function called, let's look what this order is. 1 you know, it could be month, it's probably month day year. It could honestly be day month year, but I'm going to guess there's an American data set, there's month day year, hour, minute, second of date. And let's see what we have. There it is, we've converted it. It looks pretty good to me. Let's find out what a histogram of this would look like. Yeah, so it looks like it's continuous data range. There's really, really clean data. It looks like but I haven't checked about for NAs. Actually, let's throw that into this data exploration step. I'm going to say fill is NA. I'll start with pedestrians. Ped count, pedestrian count. So what I'm going to see is it, no, it looks like some, so this data never has pedestrian counts. But we have some, like here and here, that it looks like maybe it's about half, over time it's like half of the data is missing a pedestrian count. I wonder, I'm going to throw in a quick grid and say crossing by, yeah, I'm going to put direction, probably do that backwards. I'm going to put, so passive grid is good for 2 variables here. There's not a plot for giving answers, a plot just for showing, it's probably not what I'm going to share. It's just one that I'm going to see I'm going to see where we're missing the data. No, it looks like here we have partial pedestrian count data. We don't have it all day, I guess. That's pretty strange. I wouldn't have expected that. I would have expected maybe to lose it over time or something like that. All right, I'm going to probably take a while before I actually look at the pedestrian count because that might run into some issues. I'm curious if we ever have NAs for bike count. All right, it looks like we're missing bits of data in from a couple of the crossings. Okay, that'll happen. All right, I love having dates and times because it allows me to look at traffic over the course of a day. That is over the course of like a typical day. Oh, and weekdays, which is going to be fun. Weekdays versus weekends. So I'm going to start with when in the day do we see bikers? We'll move on to pedestrians after that. So the way I'd do that would be count hour is hour of date. Hour is a great function in LubraDate. And now I can start just with hour and geom line. And I can see the, my bad. I counted it, but I neglected to weight it. I want to count the bike counts. You know, now that I think about it, I might want to summarize, or even summarize all bike count and pedestrian count with the function sum. This way I can use pedestrian count later if I want. Probably NARM equals true also. It's going to be really messy. I'm actually not going to do that yet. Summarize all. Summarize at. It was the function I was thinking of. I wanted to summarize two variables. Let's throw in an NARM equals true. Yeah, so this is a pretty familiar pattern. What does this look like? That's right, commutes. We see a peak at, I'm going to assume this is local time, so Seattle time. We have peak at 9 a.m. and a peak at 3. Sometimes when I want to look at specific dates, I like to add a point alongside the line. So it'd say 3, 4, 5 p.m. So no one would say that Seattle's city of hipsters because it looks like plenty of people work 9 to 5. So I would probably I could turn this into a graph. I could also throw in the crossings. What I can say is color. Oh nope, I would say crossing is an additional group by. Color is crossing. I like this graph. It does combine. One of the challenges, no, it's pretty good. But one thing I notice is that it combines the overall magnitudes with the the patterns throughout a day, which is really not necessarily what we're looking for. We're very interested in things like here's this one. What is that? Elliott Bay Trail looks like it's used a lot for commutes, but this Burke-Gilman Trail looks like it's a really different pattern. Bike traffic is increasing over the course of the day, so it's like no one's commuting through it in the morning, but they often are in the evening. It's interesting and strange, but it's being hard to see because each of these are on a different scale. I'm going to put crossing first. The reason I put crossing first is that now after the summarize, we still are grouped by crossing. That's a trick of group by because we often like to do tricks like this. I can say percent of bikes is bike count divided by sum of bike count. And now I can say what percentage of bikes at each point in a day. Now I can see some patterns, and being overlaid is pretty helpful. Finally, is there a way I can order this better? It's hard to say because they're all normalized, so none of them are going to have a sum greater than others. I'm not going to focus on organizing, or ordering them. Could make this interactive. The reason I'm thinking about this is that 7 lines is quite a few. And now it's hard to see, like, we're looking at purple is like spread through the day. This is a very commute-heavy driven one. Okay, but yeah, so this does show some differences of when do people bike during the day. So this, let's see, when do people bike through these crossings? When in the day do people bike through these crossings? Let's say Seattle based on crossings from 2014 to 2018. Is that data right? I'm gonna check. Yeah, I'll rerun that histogram real fast and maybe do an arranged descending date. I like to be accurate on these things. Like, it doesn't need to be exact, but through February 28th. Mostly I can say 2017, and that kind of gets the idea across, stopping in early 2018. Basically, all right. So finally, more things I would do to polish this. I would labels. I'm going to do library scales. Percent format. Whenever you get an error like non-finite location, you usually just need to rerun this. I'm going to add a few more things. I'm going to say color is, just going to capitalize. Time of day, local time. And Y is percentage of bike crossings that happen in this hour. These Seattle crossings. All right, solid graph. Last thing I do is I usually like changing the theme. All right. So we learned two things from this graph. One is there is a general commute pattern. We can see the spike here at 9 a.m., the spike at 10 a.m. But another thing we learned is that it differs between different bikes. It looks like some of them, certainly some of them are really more spiked in the middle of the day. Also, we have our late night bikers. Okay. What I'm thinking about here is that you could divide the day into, I'm going to go with 4 zones. The zones would be your commute hours, which are, I don't know, 7 through where's this drop back down? 7 to 10? Okay. And you've got your 4 to 6. Okay. What I'm going to do is say bike traffic, mutate zone. Zone, that sounds like a time zone. Time window. All right, I'll say that instead of zone. Case when is useful for this. What it'd say is when the hour is greater than or equal to. Oh, I just remembered there's a function between meant for the combination of greater than equal to on both sides. I want to remind myself: is it inclusive? Yes, it's inclusive. All right. So I'd say, where the hour is between. There it is. Where the hour is between 6 and 8, then, oh, nope, 7 and 10. So that would include up to 11 a.m. And I'll say morning commute when it's between, what would I say, 11, pardon me, and for 4 p.m. 15, midday. So midday of a dash, I'm not really sure. 16 and 4th, I'd say like a 3-hour window for commutes in each direction. Evening commute. And I'd say 18 between, well, actually everything else. I'm going to call it night, even though it's really early morning and that's a strange one. I haven't seen that before. Oh, I haven't added hour yet. Okay, so what I reminded myself there, this kind of strange error often means, in this case, it was because it was trying to pass the function hour. All right, I make this a bit bigger. Count, crossing, and oh, I meant to actually group by crossing and time window. Summarize bike count equals sum. Like, I'm not going to use pedestrian count yet because there's relatively few. Here we go. So what this is showing is our distribution across a day. All right. Something just hit me that is pretty important. which is going to say percent missing is mean is NA bike count. What I just realized is if these are like systematically off in the morning or something like that, we're going to be in some real trouble. I made a mistake here. Does anyone see what I made? This is my single most common, I think, mistake in the screencast. Is I defined when I was using this variable, it was actually using this version that was defined over here. So that's a big deal. Yeah, so I'm really glad that I did that filter. I'll show you why. Notice that this is 5%. Notice that for the for Burke-Gilman, it's always about the same percentage missing. Oh, so it actually probably isn't hurting our results. Here it's different, but it's so low. I could really say I could say just as much like number missing, sum is in a. It kind of gives the idea that this is missing a lot. Don't like this. I don't like that it's a lot more in night than otherwise. I'm still going to ignore it. It's pretty rare that we're missing bike count data, but yeah, I feel like I'm going to ignore it, but it's just worth keeping track of. Generally, what I would do if I wanted to fix is I'd remove any data from any day where any of that day was missing. Okay. So so what I wanted to do was we now have evening commute, midday, morning commute, night. We're still grouped by crossing, so I can still do mutate percent bike is bike count over sum of bike count. Now I've got the percentages during the day, and let's see, thinking about how to examine this. Okay, so I'm going to start with bike by time window. One thing I can do is spread the time window by percent bike. Before I do that, I'm going to have to remove these two columns, otherwise they're going to get in the way of my spread. I'm separating these into multiple columns: evening commute, midday, morning commute, night. That's when I remember that that's when I remember that I can add that I probably shouldn't have thrown a space into each of these. Maybe they'll be useful later in a graph. The reason I'm doing this is I can sort. I can do, for starters, I can do mutate total commute equals evening commute. I'm using backticks because I left a space in there. Not really a pro move. Descending evening commute. I actually meant to do total commute. So what we can say is that Elliott Bay Trail, that's the biggest one, and that's the one that has the largest margin of commuters. That actually gives me another way to think of this, because something I noticed about that is that's a heavy commute pattern. Okay, and so these are a few patterns that we have. I could visualize them. What I want to do is say ggplot time window percent bike This is actually, wow, that's reverse alphabetical, and it's an excellent order for these. Night, morning commute, midday, evening commute. You know, I'm not getting more out of this. I'm really not getting more out of this than I did out of the earlier graph. I mean, I can say how much ones are used for commute, but I kind of liked that other pattern. That's frustrating. Not all that frustrating. It means that I might have been thinking about this the wrong way. But there is another graph I want to make while I had this data, which was to say group by crossing, summarize total bikes. An extra, I'm missing it. Yeah. And also PCT commute, which will be the sum of bike count where string detect time window commute. I could have done that a few ways. I just wanted to say, oh, I did some. I meant this over, oops, total bikes. No, I can do this over total bikes. Yeah. So what this is doing is saying how heavily traffic is an area versus its percentage of commuters. One thing I was curious about is there a correlation? Do the busy crossings tend to have more commuters? How can I look at that? I can look at total bikes with a geom point by PCT commute. PCT commute. Definitely gonna want a scale x log 10 when we have total bikes on one axis. No, there isn't a correlation. I notice this because this is that really big one that also has a lot of commuting, but there's also some pretty big ones that have less commuting. And overall, there's not a big, not really as much variation as I expected. All right, that analysis was a little less interesting than I was hoping for. All right, I'm gonna start though. It's making me think. Here's time window. This is still pretty useful. I'm also, bike by time window. This is the aggregation. I just want regular bike traffic. One thing this makes me think of is we might want time of day and time of week. Okay, I'm going to need to remember for a second how one does this. All right, so what I really want is a graph. I'm actually going to show Stack Overflow blog late at night. This is a blog post I made when I worked at Stack Overflow of what programming languages are used late at night. So this reminded me, since I'm looking at hours of the day, I want to remind me what types of graphs I used. This graph shows that most people visited Stack Overflow morning, afternoon, break for lunch, low at night. A bit different from our bikes, since people generally don't use it on their commutes, they use it during their workday. I feel like I had another graph. This was a fun one. Ooh, I could use this. It's good. It's a solid GG animate. I could do an animation. I'll keep that in mind. I'm not gonna use it yet. No, I don't have a I didn't have the graph that I was thinking of. I want to do something that combines day of week, bike traffic. I want to do something that combines day of week and hour, but it's not. I know how I'm going to do it. Okay, so I need first to remind myself what day of the week weekday starts on. Weekday starts by default. Oh, it's the default. 7. What's that? What does that mean? Oh, I actually meant to do floor date. What I want to know is what day does it round a week to? Oh, Sunday by default. Okay, I need any given Sunday. Do you see what I did there? And let's see, as date 2019 was last Sunday. Oh, the 31st of March. It actually, I really could have picked any Sunday. If I take this and I add as diff time 13 hours. Oh, units equals hours. Didn't quite work. Oh, as bingo. If I start with, here's my date time. Throw in a diff. This is a number of hours. So what is this? I could actually say this would be 1 p.m. on a Sunday. Here is 1 p.m. on a Monday. Doesn't matter which Monday is a Monday. 48. Oop. What am I doing? Oh boy. I was going to create a date for each of these, which can be done with an algebraic formula like this. It just hit me there's an easier way to do this, which is faceting. Apologies. What I do is say weekday is your weekday of date. Day of week, and label equals true. I think it makes it an ordered factor. Perfect. That's perfect because I can now add hour. This is hour of date. I did a count. I actually, as usual, I want to group by. Could throw this in, sure. Put in a new line here. It's really confusing otherwise. Didn't get much less confusing. I'm going to leave. I'm going to remove the new line. Oh, this is not percent commute is not what I wanted. I wanted this. All right. Why is this useful? Hour by total bikes, and a facet by weekday. And I should say n row equals 1. Aha! This is actually starting to explain my midday pattern. I'm going to facet grid this a little in an even cooler way. It's going to take a little bit of more thinking. Okay, I'm going to say crossing by weekday. This is going to be a big grid graph. That's how I make this graph. I was overthinking it a little bit. Oh, no more in row in facet grid. Wonder how this looks. Not bad. The issue here is I probably want to normalize it. Not within each day, but across the entire week. So why do I want to normalize? It's because some of these, notice these are ones that tend to be shifted towards weekdays. These are ones that tend to be shifted towards middle of the week. And that explains a lot of that pattern I was looking at where some didn't seem to have particular kinds of commutes and such. Like, why do people bike on this one in the middle of the day? Oh, because it's really popular on Saturday and Sundays. Others aren't so much. Okay, so I'm going to, in order to do this, I need to group by just crossing. Mutate PCT bike is bike count over sum of bike count, and change this to PCT bike. I'm going to make it a little more interesting while I'm at it. Should the color be the crossing or the color be the weekday? I kind of like the color being the weekday, so it shifts across as we go here. But I am going to not show a legend. This is this trick I learned from Julia Silge, which is to use a redundant level of color to add like a dimension to your plot, to add extra, honestly mostly flair to your plot. I really like the effect. First I need to this, weekday this. Oh, my bad. The group by and mutate comes after the summarize. Total bikes, total bikes, total bikes, total bikes. Look at me go, PCT bike. Yeah, that's kind of cool. Is this the right visualization? I could also do color by crossing. Oh, show legend equals false was what I meant. I think I like that more. It's just really just a matter of taste, but it's just a neat rainbow effect. Especially when you're a graph where we're not using color for something else. Okay, and let me add some labels. Time of week, because it includes the faceting. Y is percentage of bike trips happening in this hour. Title equals when in the week do people bike. Bike trips should be crossings. Based on Seattle, based on crossings from 2014 to 2017. I'm going to say February 2018, feeling like I'm being misleading here. I also neglected to do a scale Y continuous labels equals percent format. So what we did was some summarizing, little lubridates, some ggplotting, but this is really quite evocative. I actually don't think I want to aggregate it further because I'm starting to realize like this sends the signal better than what percentage are in the morning, what percentage are in the weekend. We really can actually see where are your weekenders. Your weekenders are here, the MTS trail. Wow, there's a really peak in particular time, what is that? I think 11 a.m. on the MTS trail. But then you have your ones that are mostly used for commuting, like your, this is actually a challenge. It's hard to, I'm not going to get as much, this facet text is going to be too small. I think there's ways to adjust it. I'm not going to do it right now. Wish there would like rotate it. This is going to be difficult. This is going to be difficult to people in Seattle. Having said that, it is a pretty evocative graph. All right. So that's time of day, time of week. We could have looked a little more simply in terms of weekends, weekdays, but let's also look at bike traffic over time. Stop looking at time of day. For one, let's say count date equals. It's so funny this if we call the original date when it's really, I probably should have called it a date time. I'm not going to do it right now, but let's throw in a summarize bike total bikes equals sum of bike count. And I never should forget my NARM. Actually, I'm gonna leave NAs. This way, bike counts looks right. Oh, I added a count here. My bad. Oh, nope, I meant a group by. Something's up. I want to see this hour. What's that about? But also I need a color by crossing. Color by crossing. Oh, I didn't. Something's up with this one. I think based on the fact that I see, where's that gap in that data? Oh, why did I say 2018? Most of the data goes to February 2019. Looks like some of it is missing the last year, though. Like to show this. Like to show this. Still a cool graph. This one's not as cool, and one of the reasons it's not cool is that it aggregates the patterns across each day. You almost never want to do. First reason is this. I am curious what that day is, and I'm actually curious what hour that, if we can tell what hour that is. Arrange descending by count. Yeah, so I certainly don't think this is real. Head count. What did I do with? That's strange. Was that the original data? Being true or false for pedestrian count? Or is this a case? Oh no. Am I misinterpreting what pedestrian count meant? No, this isn't. This should be a number. That's very confusing. I don't know why it's true or false. It should be numeric. Okay. I am going to ignore it because I wasn't necessarily planning on using it, but I'm going to note that. Okay, I discovered there are 3 days here. I'm just going to say filter for byte count less than, in this cleaning, I'm just going to say less than 1,000. Hell, I'll say less than 2,000. Filter byte count less than 2,000. I mean, it didn't make a difference in this case. Oops. Because the only ones were a few at the 4,000, 8,000 level. But here's my byte count. I'm going to select pedestrian count just to make sure I don't find myself using it anywhere. And I can change this to just byte count equals sum of byte count. Sometimes I use byte count as the new one, sometimes I use total byte. It's a little inconsistent. I don't think it's going to cause a problem. Okay. All right, so the data is a little cleaner, but it does still aggregate within each week. That's why we see so much spikiness. What I'm going to do is change this to week is floor date. Love floor date. Very handy function in Lubricate, and I'm sure I've used it before. This, by count. Oh, I need week date. One challenge of weeks is that the first and the last week are a little funky because they're incomplete weeks. There's still a lot of jaggedness. That's not really surprising. It's sort of just random noise. Likely random noise, could be some other causes. But yeah, here we see the patterns. Ooh, there's a real seasonal pattern. Of course, people bike largely in the summer. So I'm not seeing real time trends. There's a few. If I wanted to really look at time trends, I wouldn't do week. I would do at least month, maybe year. I'm going to change this to date so that I can various however I like. I like month. It's not amazing. We're still seeing, I think there's probably some missing data at various points. I could do it by year. It's not going to, yeah, this is an incomplete year. And Elliott Bay Trail was missing, not Elliott Bay Trail, Burke-Gilman Trail was missing some data. Okay, so I'm not really going to want to look at changes over time, but I might certainly be interested in changes over seasons, time of year. A challenge that I face when doing that is some of the data being incomplete at particular points. I really want to look just at the month. How to look at the month? What I would look at is instead of group by date, I would group by month. I'm not rounding the month. I'm getting the month out of the date, like 1 through 12. If I did that, what I end up with is month 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. What I can do, month name bracketed by that. I don't know if there's a Lubricate approach, but did 1 just become April? No. Here's April. Oh, it's of course it alphabetizes the aggregation. All right, and what I need to do is ungroup mutate month equals FCT relevel month by a month dot name. There's a few ways to do this. You know what I can do? It's a little odd, but I could actually say factor levels equals month dot name, and it's gonna preserve it. I think. Let's find out. No, it didn't. It did no. Oh, ooh, no. It did no such thing. But I could do levels month name if I do month dot name. Oh, so this is me reminding myself a little. See, this is why I shouldn't. I should just have used FCT relevel. Month dot name. Stick with the forecasts. Solid. January, February, and so on. All right, I really needed to keep those levels because I was about to make a graph like this. Not like that, though. Not like that either. Oh, group equals 1. I'm doing a factor on the x-axis. That means I also need, I'm going to fix that one too. Scale x discrete. Oh, no. Theme axis text. I need to rotate the x-axis labels. X equals element text. Angle equals 90. H just equals 1. And rotate those labels. I can, let me see. I'm missing something. Crossing by, group is not equal to 1. Group is equal to crossing. Did you catch that before me? Bet you did. So there's a challenge with Burke-Gilman Trail. which is that we have no data for later in the year on Burke-Gilman Trail. There's probably other ones where we have problems like that. That means a few ways to approach it. I might just say, see, the total is so frustrating. I'm just going to say less than 2018-01-01. Only look at 3 years. Sorry, 4 years, 2014, 15, 16, 17. No point in containing years with this partial data. So I'm going to say based on, there's a subtitle, I add that right away. I say based on 2014 to 2017 bike crossings. Title is what time of year do people bike? And finally, we're going to need to have that same kind of aggregation. Switch the order so that we're still grouped by crossing. I don't need to ungroup anymore. I can do a mutate PCT bikes equals total. I've been calling it PCT bike is total bikes divided by sum of total bikes. And throw that on the y-axis. And let's do a few more clean, polishing steps. This scale y continuous labels is percent format. Y-axis percentage of yearly trips in this month. The x-axis doesn't need a label. We know English names of months when we see them. So it looks like Elliott Bay Trail is really popular in the summer. There's also ones like, so this one is pretty, it was the smallest one overall, and it looks like it is kind of flat throughout the year, which is still kind of surprising. So this is time of year. So they've really done a lot of things with graphs. We've done time in the week, time in the year, and both of them we divided by crossings. All right. So, story time. I used to commute out to New Jersey when I was doing my PhD at Princeton, and one thing I loved about commuting out to Jersey was that when I got on the train, it was completely empty, and when I came back, I always got a seat, and that was because I was doing a reverse commute. I was commuting from Manhattan to New Jersey, when most people generally were commuting the other direction to come to work in the city, in New York City. So, what directions do people commute? I'm kind of excited to see that, because remember that we have commute data, and because we see those general commute patterns by bike. That's one of the limitations. We have commute data. We have count, crossing, and direction. Some of them are north-south. Some of them are east-west. But can we see commutes happening in either direction? Do that, I'm actually going to pull this in. Maybe I'm going to delete the earlier code. I'm going to leave it for now. But I am going to group by crossing time window and add in direction. Morning by time window. This is pretty good. Percentage, each time window. I don't want that percent anymore. I'm probably going to do something else. Okay, I'm going to compare, I'm also going to do something else. I'm going to look only at weekdays. So if I look at this and I counted W day of date, throw in a label equals true, I can say filter not W day date label equals true in sat and sun. So you can say we're only looking at weekdays, and that's going to be helpful. It's going to remove some of that commuting issue, issue. Yeah, and then I'm going to ask. I only want to compare the morning commute and the evening commute, these times of day. I'm going to say after the summarize filter. I'm going to simplify this down. Remove these. It's 7. I just realized this is 3 hours. This is What was that? What were those spikes? Do I want 7 to 9? Do I want 8 to 10? I'm going to do 7 to 9 because this actually means 7 to 10 o'clock. This actually means 4 p.m. to 7 p.m. because it runs to the end of the hour. And I'm going to filter for not is in a time window. But I'm actually going to say commute time. Commute time sounds like a duration of a commute. I'm just going to say commute. Group by this, direction, commute. I'll leave in the num missing, I'm really not going to use it. Here we go. Morning, evening. Change those. Why do I change those? Because, well, I'm going to drop number missing. I'm not going to use that anymore. I can spread this. I can spread commute by count. And I can get a ratio. I can say ratio is, I don't know, evening to morning ratio. This is, wow, this is actually way clearer than I thought it would be. Here there's the 39th Avenue Northeast Greenway at North 62nd Street. Again, I haven't actually been to Seattle, but notice the north happens almost 8 times as much in the morning as in the south. Here it's 3 times as much, and this is in the evening it's about equal. But in the morning there's far more northbound traffic. This is way more blatant, honestly, than I was expecting, especially for some of these. I'm going to think about what kind of graph to make for this. I'm thinking of this being a log ratio. It's probably going to be a bar plot. North versus south. You have north and south, you have east and west. MTS trail only has one direction, so it's not going to be useful in this analysis. I'm going to say crossing is not equal to this. Remember, this is only weekday traffic. And so just I kind of expected it to be a little, some of these to be more symmetrical. Maybe there's people, there's probably people biking for, maybe there's people biking for fun in the afternoon, not just commuting. I'm gonna, so yeah, but that's me hypothesizing. I haven't found the right way to visualize this. I'm still mentally imagining it. What I'm gonna do is, here's what I'm gonna start with. I'm gonna start with direct, it's not gonna be quite the right graph. Crossing scales equals free, really critical I free the X because you have north and south, and really critical that I add a geom column. All right, now that I've done this, it's actually not helpful to have a ratio because it doesn't show 1 as the very special value on the ratio. I really need to do scale y log 10. I prefer breaks at every 2, so I'm going to do 0.5, 1, 2, 4. Can I throw in 8? One of them was close to 8. I'm going to try 8. X. Okay. The morning, and that's not so bad. But I'm going to change to make these labels 1/2, same, 2x, 4x, 8x. Labs, y is evening, bikes to morning, bikes ratio. I'm not sure I did, same time windows for each. I did notice there was usually more evening traffic. I'm going to revisit this a second. More people, but this is a solid graph. I prefer this one because it divides it by time of week. Yeah, more people, absolutely. Notice the evening to morning ratio is always, this is not looking at north or south, this is just in general, it's kind of always positive. Oh, I thought of another way I could visualize this. I'm going to start with this evening to morning ratio, but it just hit me. I did this again. So what this is saying is that people go north in the evening. But see, all of this thinking too much. This wasn't quite the right visualization. It wasn't that far. But try this instead. What if I look only at this and weekends? Aha. Okay. And what if instead of looking by commute, do I delete this? I'm not going to delete it yet. Like I said, I might return this. What if instead of looking by commute, I look by hour? What if I say, oh, there's hour? There's these filters. I like to consolidate my filters. Hour. There's no such thing as commute anymore. And I have my bike count. And I say, I want to normalize not including direction. No, including direction. Okay. So I can use still group by crossing a direction. PCT bike equals bike count over sum of bike count. Bikes by direction hour. And crossing. So this is only weekdays. So that's critical because it allows me to do a little bit of faceting. It's not going to be a 100% perfect plot. What I can do, drop this, is look by hour, just like the look before. And PCT bike, I've seen that graph. We've done that here before. In fact, wonder if I can copy. Time of, that's neat. This actually it lines up with, I think, maybe just one change. Let's find out. Anyone spot the change? Anyone spot the change? That's right, change weekday to direction. And let's flip the order of those two. I think they're, no, I think I was right the first time. Direction on the quote x-axis. Yeah. Haha. That's really pretty good. There, you can spot the challenge here, which is the east-west commuting direction. Which, oh, this is so cool. The one that goes east-west, which is, what is it, a greenway? This is something street greenway. This one actually doesn't show a commute pattern. Wow, I'm going to keep it. Am I going to keep it? I'm not quite going to keep it. Okay, I am going to filter out that case. I'm going to say filter direction, not. It's so cool though, the fact that the one that goes east-west, the west doesn't go in the same direction. But I'm only going to go for the ones with north-south. That's a pretty great graph. I'm also, there's a way to order this, which is when did the average trip happen? It sounds funny, like average trip, how would I do that? Would I do mean hour? Well, no, hour is always 1 to 24, but I can do a weighted mean by its percentage. What I'm saying is I want to order my crossings. What I'm going to say is FCT reorder. Checking how can I do this? Oh, okay, I'm probably going to have to do a touch more work. Yeah, what I have to do is group by crossing, mutate to add a column, average hour. That's going to be the sum of hour times PCT bike divided by the sum of hour. Feels right? Yeah, I think so, because basically the higher PCT bike is across these, the higher it tends to fall within the hour. This is a bit of a complicated operation. Might take a little playing around to see why you can do this. And maybe you can't. Maybe I got this wrong. I feel like I got it wrong. Let me quickly check. Distinct crossing average. See, because I expected these to cluster together. Oh, this is wrong. What am I doing? Well, for one thing, I don't need to do this, but that actually shouldn't change it. I don't think. But, group by, this is actually kind of neat. It's, they're balancing each other out. I'm going to do it slightly differently. I'm going to say where direction equals north. The problem was I was aggregating across the entire crossing. That's perfect. Okay, this ordering, only 5. So we had 6, but one of them was east-west. Didn't really show a commute pattern. This shows how people commute. These are the ones where people go north in the morning, south in the evening. Oh, why am I faceting? I could really color this, and I think it would look pretty great. Let's check that. If I say color equals direction and facet, I'll still grid for now. Color equals direction. And I need to show legend now. Also, I want the crossing like this. Is this as clear? North, south. Throw in a quick label. Is this clearer? Yeah, I think it might be. Okay, I'm going to use this. I'm not sure. They're both pretty solid at communicating what I want. So I'll change the title. What directions do people commute in by bike? Based on weekday crossings. That's a critical filter. Do Seattle. In which directions do Seattle residents commute by bike? It's complicated. I'm going to throw the word Seattle into that. This is so... I feel like I need the word Seattle somewhere, but it's not. It's kind of awkward. It's very, very awkward there. I'm going to skip this and just assume at 6 Seattle locations. All right, that's pretty good. It's not amazing, but it's yeah. This would be a story. Elliott Bay Trail. People go north in the morning, south in the evening. Seal Trail. People, same thing. The Burke-Gilman Trail. People don't commute quite as heavily. Same with this cycle track. But wow, there's an absolute pattern. People go south. This one, it's hard to read. People go south in the morning and then north in the evening. In this hour, I could say in this direction, this hour. I think it's basically clear. Okay, so what's interesting here is we look just at Seattle data. I don't know anything about the geography of Seattle, but I bet you we've said something about geography. I bet you this is a downtown is south of Seattle's downtown of its commercial district, because everyone's heading north into the commercial district in the morning and south in the evening. Similarly, I bet this so Elliott Bay Trail, I bet, is south of the commercial district. I bet you, wish I could read that. That's my biggest regret about this graph. Any greenway at, maybe we need to shorten them somehow. 39th Avenue, Northeast Greenway, 39th Avenue, and Northeast 62nd Street. Okay, I bet you Elliott Bay Trail. Let's take a quick look at Seattle map. I don't know where the downtown is. Maybe we can tell from the texture. Again, I really don't know my way around this geography. My best guess would be here based on just the shading. This is Industrial District. There's a Space Needle. Okay, let's say this is downtown. Where is Elliott Bay Trail? Did I spell this right? Elliott Bay Trail. Elliott Bay Trail. Everyone's going north. It's actually not quite what I would have expected. This looks kind of downtown, but this is suggesting people in the morning go north, people in the evening go south. Like I said, so this is just a lot of the jobs are north of there, and a lot of the residential areas south. Uh, I don't know, not what I expect. Oh, unless actually this could be really long. What am I doing? I'm trusting just this one. I wonder if it has any other detail about it. Uh, Elliott Bay Trail. It doesn't say where in the Elliott Bay Trail. What if it's down here somewhere? We don't know where exactly where the Elliott Bay Trail is. Okay, that's one thing. One side. There's also then the 39th Avenue and 62nd Street. And my bet was that this is north because everyone goes south in the north of the commercial district because everyone goes south in the morning, north in the evening, and that's yeah, this one. Well, I even lost my way around this. South in the morning. Oh, south in the morning, north in the evening, and in fact, yeah, here it is, and it looks like a lot of stuff is south. I'm judging based on the coloring. Like we have certainly this downtown area. I don't know if that distance is bikeable, but these areas, okay, it is much more north than the Elliott Park is. So we only are observing 2 points here. If we look at the others, it'd probably be even more ambiguous. But we're able to tell something about their directionality relative to the commercial centers of the city. So that's fun. That's really fun. I wonder if the I'm not going to take a look, but I wonder if the article looked at some similar things. Okay, so it's the time we have to review. We downloaded the bike traffic. We looked at what time of day, and especially I like this graph, when in the week do Seattle people bike, and see that many people do bike. It looks like as a commute, as in the mornings and the evenings. Some popular, like the MTS Trail, are popular on the weekends. Others, less so. We then looked at what time of year people biked. We saw in general much more popular in the summer than the winter, but it does depend on the crossing. Finally, we looked at what directions people bike in. I can now delete this code because I discovered the ratio is not what I want to look at. This was the right visualization. I knew what I was looking for, but I needed to try a few visualizations. And looking back, I should have trusted right away the line plots. We've had a lot of success with line plots through this analysis. And really, in the end, that's all we created was 3 line plots. I need to change this to time of day. Yeah, that's I think I probably, like I said, I should have come up with this right away, but we certainly did eventually and learned something about commuting by bike patterns in Seattle. That's really fun. All right, I had a great time. We're looking forward to the next data set. I'll see you next week.